in case of damage, flood damage in particular, when a raised floor system gets wet, it must be opened up and dried out completely before it is re-insulated. The typical insulation choice that we will find in villages are fiberglass batts. There are several reasons for this. They ship well, they require minimal skill to install, and they are what was an industry standard insulation for many, many years. And before you can put fresh batts into a floor, you must make sure that that floor system is dry. Once you put a new subfloor on and underfloor sheathing, that drying process will slow down, and if the floor isn't completely dry, you can risk having mold and rot in that floor system. In this video, we'll be looking at several job sites and discussing some of the scenarios that a retrofit crew may run into, and we'll also be covering some of the concepts that are required to yield a good product and an energy efficient floor system.
Can we pull up a couple more of these boards? I just want to see a little further down.
Okay.
That's why we're seeing. That was a good shot.
Good and bad. We don't have to crawl under the house to get them in.
Well, let's rip up the rest of the plywood, stick it to one side, see if we might be able to use that as a subfloor, and we got to get the belly boards out. Well, let's get it ripped up.
Aye, aye.
We got a few days on this one.
That could take a while.
Sometimes retrofit and flood damage work involves compromises, and this is a good case in point. Insulating this floor from above, as we would tend to do in new construction, just is not possible. Instead, this house was cribbed up to a working level of about 3 feet. The wet insulation was stripped out, the floor system was allowed to dry, and now the workers are putting fiberglass batts back into the joist bays. A couple of pointers that make a job like this go a lot better in terms of energy performance is find a good insulation that fits snugly between the framing centers in the bays and that fully fills the bay. This insulation is touching the subfloor and it's hanging down just a little bit. That means that when the underfloor sheathing goes on here, it will slightly compress that insulation. That bay will be fully filled. There won't be any undesirable air spaces between the top of the insulation and the subfloor. Remember that air currents and wind-driven air pressures going through these floor systems will rob that floor of heat. Fiberglass batts are glass fibers with countless tiny little air spaces between those glass fibers, and this insulation only works at its best if there is still air trapped in between all the little fibers in the batt. As soon as wind starts going through this fiberglass, you start losing energy performance. So this fiberglass batt should be fully installed into the bay, and the underside of the floor should be as well air sealed as is possible under the circumstances. In this particular retrofit, the insulation that was damaged, water damage in the floor, was taken out. The floor was allowed to dry, and then more insulation was added, more fiberglass batt inside the joist bays. But to boost performance, an inch of foil-faced EPS foam was added across the bottom of the floor. It was also taped at every seam. The idea is when you add foam board across the bottom of a fiberglass batt insulated floor like this, the entire floor system performs better. The foam board creates a thermal break, so you're stopping heat losses through thermal bridging through the floor joists and taping the joints in the foam board, and because it's sheet stock and takes up large surface area, makes it a very good air barrier. So you're also stopping that added effect that wind can have if it washes across the bottom of that insulation. So you're stopping heat losses through thermal bridging, and you're just making a tighter floor system. It can be a big boost in performance. In this next video segment, we'll discuss how to install fiberglass batts in raised floor systems under best practices conditions. We'll also cover how fiberglass batts work and installing subfloors over fiberglass batts. I'll be very clear though, and some of the footage from the job sites will underscore this, that in a retrofit situation, when you're insulating a floor system, it's not a perfect world, and there will be times where you simply have to do the best job you possibly can, but it may not be perfect. That said, if you understand the concepts behind what it takes to install fiberglass batts properly and air seal the floor system, you will still end up more than likely with an end product that is more energy efficient than the house was in its original state. When you install them, you're going in, you're running your hands along the sides, so you're sure you're getting full contact and the insulation's going all the way to the bottom, not that it's folding up on a corner or anything like that. We snug it to the end, check and make sure we've got full contact in the corners, and then pull it up a little. This is the type of fit you could expect if you're going to maximize your insulation performance. Also note the fiberglass is slightly proud of the top of the joists. That means when the subfloor goes down, you'll have full contact and you won't have any voids or air pockets under there. And you can adjust all this when you put the subfloor down again too, in case it gets bumped or somebody steps on it. If you can frame your floor so that you're insulating from above, your performance is probably going to be a lot better because you've got a lot more control over how you're putting in the batts. You're not underneath fighting gravity. The batts always tend to want to fall away from the subfloor at that point. You may see me fussing with little parts and pieces here, but that's giving you a nice, uniform, even fill, very consistent, no folded over corners, good contact all the way down the joint between the batts. What you're trying to do is create a very uniform insulated cavity, absence of voids, air pockets, things like that. If you get a uniform product, a good install with contact everywhere, you're going to have a much better performing product. So take a few extra seconds of time and make the adjustments if you see they're needed. If we look at all the insulations that we typically use in residential construction today, whether it's foam board or cellulose, like we've got here, or blown-in fiberglass or fiberglass batts, one thing that all these products have in common is they depend on capturing either air or some other kind of gas inside that product to resist heat movement through it. Now, if you're looking at something like foam board, the way it's structured, it inherently resists airflow, such as wind moving through it. Now, the way fiberglass batts are made is you've got a matrix here of many, many tiny spun glass fibers held together with a binder. And in the spaces in between all those fibers, you've got millions and millions of tiny air pockets. And it's those air pockets that are giving you a lot of your thermal resistance, your resistance to heat flow through the insulation. Now, if you've got a raised floor system like this and it isn't air sealed properly, then you're going to be vulnerable for air movement through the joist bays. And here we can see we've got this gap on the side and we've got a gap on the top. These places are paths of least resistance for airflow, and they may be especially vulnerable if you've got wind or other forces that are moving air through the floor system. The bottom line here is that in a fiberglass batt installation, air sealing is going to be part and parcel of getting optimum performance. And later in this video, we're going to cover some techniques that we're going to use to air seal this floor system. The question often gets asked whether one should put 6 mil poly over this floor system before nailing down the subfloor. It is a very logical question to ask because in cold climate construction, we're conditioned to do a meticulous job of installing 6 mil poly on the warm sides of our exterior walls and on our ceilings. The idea is the poly prevents moisture from migrating into the walls and ceilings in wintertime. So why not the floor? Well, I think the risk here for trapping water with this poly is pretty good. If any rainwater gets past the subfloor, or if you've got a significant spill over the life of the structure and that water pools up on this poly, it's going to have a terrible time drying out. So we'll ditch the poly. And looking at this subfloor right here, whether it's 3/4 inch T&G OSB or whether it's plywood, both of those types of sheathing are resistant enough to moisture travel by diffusion that they'll do an adequate job of keeping water vapor out of this floor system in wintertime. Also, the American Plywood Association recommends using subfloor adhesive to glue down the floor to the joists in addition to nailing. The subfloor adhesive makes for a stiffer floor and reduces nail pops and squeaks. So in this case, we're going to install this floor system as recommended by the manufacturer, and we won't be using the poly. As every sheet goes down, I inspect all the bays that are going to be under that sheet and make sure that the insulation is pulled up and lofted so that it's got full contact to the subfloor when I nail it down. The path of least resistance is any air gaps in the insulation. So if you've got an airspace between the subfloor and the top of the insulation, that's where your air is going to travel. It could make this floor seem uncomfortably cold. Also, if this floor system's been exposed to weather, rain, or if the lumber's wet, it should be quite dry before the subfloor goes down. If you lower this sheet slowly rather than drop it, you're less likely going to have that volume of air displace this fiberglass, press it down, or cause it to squirt out sideways on top of the glue, so you'll get a better result. So, going down nice and slow. When it comes to framing, gaps are going to be unavoidable, and in this case we've got a slight difference in height in lumber and the timber is rolled slightly. Although when I do put the subfloor glue down, I'm going to be more generous around the perimeter because that's certainly an air infiltration point. Any way you slice it, air leakage through building enclosures is a problem. What this floor system is doing, in addition to providing structural support, is it is acting as a primary pressure boundary. What this means is that this floor system is also serving as the air barrier that separates our indoor air from the outdoors. If you're going to be drilling holes in this floor to run mechanical systems, to run wiring, to run water supply lines, to run a main drain line, those penetrations need to be given the same attention of detail and air sealing that we would give them if they were in an exterior wall or a ceiling. The dominant path for airflow through a floor system like this is from outside to inside. Stack effect tends to draw cold air in the lower regions of a house and leak it out through the upper side. Does that mean the holes are a good idea? Heck no, it's still an energy drain, but we're at least a lot less concerned with warm, moist indoor air finding its way in through cracks and holes in the floor system. Cleaning the floor with an air gun is going to go a long way towards having better adhesion. If you're going to be caulking in the joints, getting rid of all the dust inside there is going to ensure a better bond. If you're going to be taping over the top of the joints, then any dust that's on top of the subfloor is going to interfere with your long-term bond as well. Probably one of the quickest ways to do it would be to run some caulking right in here into the joint. The caulking should be flexible, long-term, and have good adhesion to wood. You can usually do it with minimal mess. If there's some extra, you can always trowel it flat so it won't interfere with any underlayments or anything else that's going down later. In flood damage situations, often the walls are affected, and in cold climates, exterior air sealing the exterior walls is very, very important. And in many cases, older houses were not air sealed well to begin with. And in some ways, one can look at flood damage as an opportunity to reseal and better air seal the existing home, simply because you already be going in and removing drywall and replacing insulation. So we'll cover the best practices approach to air sealing walls, and we'll also do some site visits and look at some of the existing situations which you may come across that will challenge your abilities to insulate and retrofit. What we have here is a roll of 6 mil thick polyethylene plastic sheeting, commonly called 6 mil poly. This is an industry standard in cold climate construction in the northern climates and in Alaska in particular. This material is used behind the drywall to stop moisture movement into the building assembly during the heating season. Now, when we call this a vapor retarder, what we're referring to is its high impermeability slows down moisture travel by diffusion through the wall assembly from the warm side in wintertime. Now, moisture travel by diffusion refers to water, except water in a gaseous state. And different building materials are going to be more or less permeable to water vapor traveling through it. Drywall here, for instance, is quite permeable to water vapor. And so the idea here is that if you install a layer of 6 mil poly over the studs behind the drywall, it will slow down moisture movement by diffusion into that wall assembly in wintertime. Of greater concern to us, though, is moisture movement via air leakage. We still have the same water vapor, but much, much greater amounts of that water vapor can travel into our building enclosure via air leakage. So the idea here is this vapor retarder not only has to act as a diffusion barrier, but it also has to act as an air barrier. That means we have to install this 6 mil poly so it's as airtight as we can get it to minimize the amount of water vapor that travels into our building enclosure. In order to do a good job air sealing our vapor retarder, we need to glue it down right here on the subfloor. And this is one mistake that people make, is they will run the acoustical sealant, the caulking, right along the sill plate, but that still leaves this joint open right here. So to get the best possible bond, we need to make sure the subfloor is nice and clean right along the base here. Now with my poly installed in a nice straight line across the top of my wall, I'll start in the middle and I'll work my way down. I'll push in the insulation where it's bulging. I'll check over the studs just to make sure there's no insulation folding over. And then I can start stapling down. Now we don't want to staple all the way to the bottom. We still want to be able to lift here and be able to caulk right along on that subfloor. So we'll hold the staples up 4 to 6 inches. When you're stapling around your windows, try to hold the staples to the outer edge of your framing. The idea here is then when you trim the window poly out of the way, you've got room to slide the nozzle for the caulking gun in there and apply acoustical sealant all the way around. The idea here is to get this poly on nice and flat and straight with a minimum number of staples. I don't saturate the poly with staples. I just put in enough staples, maybe every 16 to 24 inches as needed to hold this up. Tremco acoustical sealant, that's another industry standard that we use for sealing poly, whether it's poly to poly between joints or sealing poly to wood. It's got excellent long-term adhesion and flexibility, so it's a great choice when it comes to air sealing a vapor retarder. So what I'm concentrating on doing here is installing a nice generous bead right along that joint where the sill plate meets the subfloor. If you've got a barky edge, then just concentrate on running that bead right along the subfloor where the edge of that sill plate would be. Some people will just tape the poly to the sill. I think it takes a little bit of extra effort, but I like the idea of having a really good seal right between the poly and the framing. So I'll run my bead of acoustical sealant all the way around the perimeter. This is a really common mistake that people do all the time, and that is putting the poly, overlapping the poly in an unsupported joint. And usually it runs right across a series of stud bays, just like this, with the poly bedded in. Stapled every so often. Maybe it makes it, maybe it doesn't. Maybe it's got red tape on it, maybe it doesn't. The problem is this is not a fully supported joint. It's only stapled every couple of feet. All this right here, A, it's got some wrinkles in it, but B, there's no guarantee that over time this won't leak air. And so this just helps to illustrate the importance of having a fully backed joint. If you were to do this, you'd be much better served doing it on the double top plate or splitting it right here where we've got a roll of horizontal blocking. But don't do it in the middle of an insulation bay without support. Whether you're using red tape or acoustical sealant, it doesn't yield the same results. This is an older home that was damaged by flooding. The flood water came up to about 3 feet, but generally in cold climates where you've got water damage and you have to replace insulation, it's often better just to cut the drywall away all the way to the ceiling, because now instead of trying to fit to the existing air and vapor barrier, which has been haphazardly cut off at the 3-foot level, you can replace all the drywall and put a new vapor retarder in and do a good job of sealing that at the top of the bottom rather than trying to patch something in unsupported at the 3-foot level. But what the deal with that is that this can be swept out, and there should be enough plastic. Ideally, you should have 3 inches or so hanging into the floor.
Yeah.
Then run that bead right on the subfloor there all the way around and bed it in.
Got you.
The tape is, as soon as the tape gets just a little bit of dirt on it,
What about
quits being sticky.
penetration?
Where you have a staple, we're not concerned because the drywall will pretty much gasket over it. If there's a tear in the actual plastic, then I'd red tape it or make a patch.
Okay.
Sealing's going to be tricky. Nail's got to come out, but just tie into this existing vapor barrier with the acoustical sealant, and then just bed this guy over it.
Okay.
And there'd be maybe places where it's going to be a struggle, and I'd say just do the best you can to get in there. It's kind of the curse of having to do something like this, but at least it looks to me like at least you can get to virtually all of it.
Yeah, the worst of it.
Yeah. Sometimes old houses like this yield a few surprises because they've been through a few remodels, and sometimes that is not a good thing. And here, when we pull this insulation away, we see something that's concerning. It's not uncommon. People think, aha, I'm going to improve my air tightness and energy performance by adding foam board insulation to the outside of my wall, then I'll put new siding over it. Well, the problem is the foam board itself is very impermeable, and we are putting a plastic vapor retarder on the warm side, so all of a sudden we've created what people sometimes call a double vapor barrier. In the wintertime, all that moisture, that water vapor that we generate, it's a gas from cooking and eating and showering and just living in the house. That gas can travel through holes in our vapor retarder. This vapor retarder is never perfect, and if that air leakage takes any water vapor through that fiberglass, which is air permeable, and that air leakage makes it all the way through here, this is cold enough now to be a condensing surface, and over the course of the winter, that water vapor can condense on this face of this wall, and it'll have a heck of a time drying out because it can't dry through the foam very well, and it can't dry back through the plastic. And so it's much better not to put foam board on the outside of the wall, but if you're going to add some foam board insulation, strap or fur that wall out and put that foam board insulation directly in front of this vapor retarder or directly behind it. You've still got a drying path to the outside. Your foam board insulation's on the warm side of your wall where it won't attract condensation.
Expert opinion on this.
I think this room is fine. It's actually probably insulated better in the walls than the other rooms, you know, and the vapor barrier should go back over this and tie into this and seal to the floor like it was. And it's kind of chopped up here, but you'll just have to do the best you can to make a good air barrier right around the lid. That
Yeah,
should do it for
little
you.
areas like this. I mean, you just stuff them with batt best you can and put
My-
a moisture barrier over.
Correct. You guys are operating, my understanding is, on a make-whole agreement, so this place needs to be restored to what its original state was. My opinion on that is you guys are already doing a better job with the vapor barrier than was done originally.
Okay.
Because back in the day this place was built, they didn't take any time with the plastic if they even used it. If these boxes are going to remain, I don't know if they are, but if they could be siliconed on the backside, that'd make, you know, just around where the wires come in, that'd be less air leakage.
That's how you skin that cat, huh?
Well,
that's good to know.
It's a problem for us because this is an old, probably 40-year-old box. Now they have a gasket and everything.
And
on
I'm
the new
being
one.
a little bit self-serving here when
Sure.
I answer this question.
The deal is you can't silicone. You can inside the box, but it's better to do it outside because if you mess with the cubic inches available for wiring inside the box, theoretically it's a code violation. Doesn't mean people can't do it, but
Yeah,
you're better off doing it.
I hear you.
Yeah. What we'd much rather see is a modern vapor-tight gasketed box that you can seal your plastic to.
Well, what they want us to do is cut.
You guys didn't happen to see out here in the
Yeah, this is a typical thing is the plumber came in before the insulators were done, jammed the tub in place and went on to the next house. So you're going to freeze a trap, and that's probably what happened. But definitely pull this drywall off and get back in there and either run foam board back there or batts and vapor barrier air seal it if you can.
There's something back there.
There's plastic back there, but it looks like it stopped at the tub.
I think I'm gonna wear my hard hat.
If you guys go up a little further later and have more room, I'd say keep this here, but then slide foam board down and just put 3.5 inches or so of foam right against that sheathing, friction fit it in there.
So should we stuff as much batt in there as we feel that cavity there?
If you can get under the tub with batt, but I'd still put foam right in this bay here, foam board.
Which I definitely will.
I'd fiberglass it. More is better.
Feel that cavity.
Yeah. If there's any piping back there, I just make sure the piping's on the warm side of the insulation. What gets people in trouble is they'll try to wrap the pipe in insulation, and then you get a freezing problem. Behind this tub, there was no insulation put in, likely because the plumber installed the tub before the insulation went into the house. So for many years, the plumbing froze here, and the occupants complained about it being cold back here. This needs to get torn off. Foam board insulation should be added here. If you can't get the vapor barrier down further, it's also an air barrier. Instead, replace that with foam and spray foam that bay, then close everything back up. It's not an easy project. Repairing flood damaged homes is problematic sometimes because you may walk into a situation where it's very difficult to take existing performance and improve it dramatically without completely remodeling the house. But it is possible to make differences in smaller ways in certain sections if the opportunity is there. And in this case, this bathroom floor was severely damaged by flooding. It actually collapsed, so the entire floor system had to be replaced. It is a raised floor, and so the workers put a new subfloor down with another 12 inches of fiberglass, clean fiberglass batts, but it didn't take much extra effort to add another 2x6 floor on top of this insulated floor and put the tub on top of that. This uninsulated 2x6 floor allows for a safe place to run the water and drain lines for the tub. Before, they were in this insulated floor and there was a constant problem with freezing. Well, with a little bit of extra effort, now all the plumbing here is frost freezing protected, and the floor is performing at a pretty good energy level too. In cold climates, repairing damaged existing structures is never easy, and flood repair is particularly unpleasant because the site is never clean and there are always obstacles that one must work around. And in retrofits, that's a big challenge. It's not a perfect world, and there will be many times where you can't install insulation or air seal to the best practices approach. All that said, keep in mind that many of the homes you are working on were built many years ago and to a much lower standard than you are working to today. And so if you do the best job you can and you follow the best practices principles, the end results will likely be much better than the house was when it was built initially.